My name is Yuri, and I'm going to start a presentation of software-defined network for Alagoas Federal University. Software-defined network allows network administration to programmatically initialize, control, change, and manage network behavior dynamic via open interfaces, providing abstraction to lower-level functionalities and new functions that are needed in nowadays global networking. Before I begin the explanation of SDN architecture, I will provide a bit of story. In 1995, Java was released by Sun Microsystems, and in the same year, Geoplex was released by AT&T, and they decided to use Java as a means to create some sort of the primitive middleware to transmit and update companies' policies real quick. Therefore, it was being created the first SDN prototype. AT&T was proved correct to use new sorts of internet protocols. We can see examples nowadays with change of traffic patterns being before north-south patterns being one single client machine and communicate with a single server machine, and nowadays having several server machines, several data centers communicating and then providing an answer to the client. With the consumerization of IT and companies embracing new technologies like mobile devices, it needed to provide those mobile devices with internet corporate connection, maintaining security and disconnecting as quick as possible. The SDN also helps with that. Enterprise has embraced the public and private cloud services, and now those business units want the agility of access applications, infrastructure, and other IT resources on demand. Increased security, compliance, and auditing requirements are needed, along with business reorganization, consolidations, and mergers that can change assumptions overnight. All these qualities are only achieved by having SDN network protocols. SDN is as well needed in the explorer of big data centers. Handling today's big data or megadata sets requires massive parallel processing on thousands of servers, all which need to be directly connected to each other. The rise of megadata sets is fueling a constant demand for additional network capacity in the data center. The SDN protocol divides the network protocols into three major planes, and I shall explain them following. In the application plane, we have SDN applications, were composed by SDN app logic, the core itself program, and NBA driver or drivers. Those drivers communicate via SDN northbound interfaces NBIs to the NBI agent in the control plane. SDN applications are what in-core the network admin uses to administrate the network and change little values or politics. The control plane is centralized in the SDN controller, whose primary function is to translate the requests from the application plane to the data plane. Also has a function of providing the application plane with abstract view of the entire network. The SDN controller are composed by NBI agent, who basically put together all the NBI drivers and commands, and the CDPI driver, who is the control data plane. In the data plane, we only have the SDN data path elements, who are intern of the network element itself. The SDN data path are composed by the CDPA agents, who basically receives the commands and forwards them in the network elements, and one or more forward engine, zero or more processing functions. Those engines and functions are responsible to manage flow control and other minor things in the network element. We can have one or more SDN elements data path per network element.